Okay, well, in Rebecca's first slide, she presented what I was planning to say, which the issues that we have are diverse locations, heterogeneous data, and lack of software tools. But since I have half an hour, I'll say it again. So, and first of all, by background, I wouldn't say I'm a trained computer scientist, but we can get into that. But I'm a computer scientist, and my view of computer science is we are tool makers. And so my goal here is like, what tools do you need? I think Rebecca referenced, continually looking for available tools. No. Go out and specify the tools you need. And that's what we live for, is new problems. And I also wanted to make the point about machine vision, machine learning. Machines do not see, machines do not learn, people do, and we're making tools to extend what people can see and extend what people can learn. And what I wanted to talk about is there's all this great promise. I mean, you're reading all this stuff that AI and so forth is going to make happen, like what's standing in the way? And my view is lack of data, particularly some kinds of data, not quantity, and the lack of tools. So I just wanted to present a few thoughts along these lines. And I thought I'd start by ripping from today's headlines. One long-term project that I work on fits and starts is learning about stone weathering from the point of view of computer graphics, how to make realistic models, and from the point of view of conservation, what are the mechanisms, how can we avoid it. And so one thought for many years is, we can get pictures and scans of objects today, and these are sculptures from Notre Dame. And we can see all of the stone loss that there is, and we can estimate the shapes and so forth of these. And we can learn something about the stone weathering process by looking at historic photos of the same things. Monuments of this sort people have been taking photos of. But it turns out to be really difficult to get photos and reliable photos, even though there should be collections. We can see from the ones we find that there's been tremendous loss. This is an image from a postcard that was for sale, so unless I wanted to cough up the money to buy it, I have no idea where this was taken and when it was taken. Useful pieces of data that you need if you want to conduct this kind of study. This one's really weird. It's from a poster that Walmart's selling that is based on an old postcard, so it really have lost where it came from. But what's interesting is there's not as much loss here. So like, where on the building is this? Why is there less loss? And then aha, here I have a picture that is from the Yale Visual Collection. I must have all the data about that. I can finally know, where was this taken? When was it taken? Well, it probably wasn't taken in the published created date of 1220 to 1240. So I don't know, if there's no information on the postcard, if this was what was on the reverse, or if somebody just assumed that when people looking through the visual collection, they were interested in the cathedral rather than stone weathering. So all the sort of missing data that either wasn't entered, or if somebody had it now, can't enter right now because this is a fixed asset. To a more successful project from a colleague in France who's studied Notre Dame a great deal. He has studied these kings in front, which of course, on the theme of we've been losing Notre Dame for a long time, these are not the original kings. The original kings were removed and beheaded I'm not kidding, they took down the kings, the stone sculptures of the kings from Notre Dame and publicly beheaded them in the French Revolution, and only in 1977 the heads were found in the back of somebody's house. Anyway, so what he did was studied the heads and the remains in the cathedral, which they have also 3D scanned. There's been a lot of news media about the guy at Vassar and Assassin's Creed and other people but obviously the French have also. Anyway, he examined remnants of colors on the heads and on the structure. So bringing together this theme of having to bring together lots of sources, just like you have the lots of sources. You have this purple flower, but there's all this stuff you've got to bring together. And he also brought together imagery of how the light changes on the front of the cathedral at sunset, and did some hypotheses of what the cathedral actually looked like in medieval times. So the point here being, that the learning requires assembling heterogeneous data sets from many locations. So with those themes, I just wanted to talk about, three aspects here, using 3D, 2D, and organizing collections. And I realized I don't have the time here, so would you do this? Okay, so in 3D, I mean, so for, as far as computer vision for 30 years, probably you say 40, we've had all this research on how to do active scanning and photogrammetry, and these are projects I've been involved in, and of course there's been thousands and thousands all over the world in capturing 3D of cultural heritage and natural history collections. And these are good for some individual studies, like these are studies of one of Michelangelo's Pietas. How was it meant to be viewed? What did it look like when Michelangelo broke it apart before it was repaired? These are from the Egyptian Museum in Cairo. How were these objects used? And here from a study that we did at Yale, a special exhibit that brought together many busts of the poet of Alexander Pope by the same artist, Roubiliac, scanning all these to compare how the representation changed over time. I should say the Smithsonian has spectacular 3D scans, and particularly I was taken by this one. This is enormously technically difficult, must have been to challenge, and incredibly informative. It's the inside of Apollo 11, which hopefully everybody will visit this year on the anniversary, and it's got great data about it, including this little nugget about astronaut graffiti that I wish they said more about. I'd like buzzes. What do you mean astronaut graffiti? Also, there was a later talk is activating artwork at the Hirshhorn. I don't know if people at the Hirshhorn realize that this sculptor by Farron inspired a graduate student named Cindy Gorel to start a whole line of computer graphics research that goes on today in a form in so-called global illumination. And this is the Hirshhorn's official picture of it, which is pretty good, but she had this one taken to emphasize this lighting effect that was the inspiration so there was a model built to show this is in 1980 or so, how well we could have simulated the lighting on this, and by the end of the 80s, the improvements in lighting algorithms. So another modeling little anecdote that's associated with the work at the Smithsonian. Anyway, so there's a lot of examples of scanning, like thousands and thousands of scanning for documentation, scanning for public communication, but not that much. What have we really learned? What kind of analysis that we do that gives us new insights into the past from these? So a group of us got together to sort of review the literature and find out, particularly with respect to geometry, that's what 3D scanning's about. What have people actually learned? And we developed a taxonomy for this as far as numbers of objects, scale of objects, types of application. I won't bore you with the whole thing, but most of it is either improving legibility or doing restoration is what people have done so far. So making tablets, cuneiform and so forth easier to read. Reassembling broken pieces. This is from Benedict Brown's work back when he was at Princeton, but putting together, in this case, frescoes. There's another case of Irish tax documents that were damaged in a fire and that were scanned with photogrammetry so that they can be digitally flattened and read. This is from University of Kentucky, where they do CAT scan, volumetric scanning of fragile documents so that you can virtually unroll and read them. And then there's a lot of projects which borrow from fairly standard engineering and other aerial survey techniques to do things like monitoring of historic structures, or in this case, the same sort of thing you might do for like crop management or enemy surveillance using aerial data to understand usage patterns. So a lot of work that involves basically a single object. We haven't seen much with collections. This is a little bit of work on that line where looking at sets of coins and finding the same figure across several coins that were found. This is another studying the faces on the Banyan Temple in Cambodia, with the goal immediately, the immediate goal of trying to do restorations. This is one true collection study where these are figures 3D scanned at the Louvre to try to determine provenance for pieces that, their origins aren't known. And this is a study of a smaller collection of busts of Augustus that were done to try to find the relationship of when the busts were done and by whom. But overall, in our whole survey taxonomy, the collection analysis, which is like the big thing we can do, to do things at scale, is a very empty space right now. So what is the problem? Why aren't we doing more about bringing objects from different museums together and doing these collection analysis? And I think there's two things. We have a lot of very small collections that are scattered geographically, and they are often lacking contextual data that would make them useful. I mean, this virtual curation lab, which shows up on Sketchfab, and if you're not like sort of a computer game builder, you probably don't use this site much, but it's where people park a lot of computer models because you can. And it takes a lot of effort to build this site. This is, I think, Virginia Commonwealth University. But the models there, for the most part, they're simplified from what they were originally scanned because, just so that they can be displayable at home. And there's very little contextual data. And it's kind of a smattering of stuff from all over. It's not apples to apples kinds of studies that we'd want to do. SciArc, which for many years has been going around the world doing large-scale scanning of structures, has made all of their data open now. So there's dozens and dozens of sites ranging from huts in Antarctica to cathedrals to Cape Canaveral. So a lot of diverse places. And there's no lack of quantity of data. There's gigabytes and gigabytes and gigabytes, but it's still like, it's not clear, how can we make use of this? What do we need? Is it just managing the sheer volume? I think we also need contextual data that goes with it to understand what we're trying to study, what questions we're answering. Just shifting then from 3D to 2D, where obviously there's been a lot more success because it's one less D. So like, for example, we've had work here in studying medieval manuscripts, where a lot of work has been, it's the same thing. There's many manuscripts in many different places, so viewers have been built that can take, standard representations so that you can take manuscript pages from many different sources and read and compare them. This is work mainly from Stanford in collaboration with Yale. On our side, we did some various test cases to illustrate studying large quantities of pages, both their layout and their spectral reflectance. The layout is of interest to identify things ahead of time, sort of adding data to things so that subsequently when people want to ask questions, it's easy to access the results. And so it's layout, not so much the words. I mean, these are from books of hours. I mean, they're prayer books. Everybody knows what they said. That was kind of the point of them. But what's interesting is the different ways that they are laid out and spotting things like these. I don't have an arrow either here. These little bars that indicate that this is poetry as opposed to the main text. So we did a lot of work, consistently identifying layout across, and the challenges in these manuscripts being lots of damage and things missing and variety of that sort of thing. We also did a study of the apparent color of pigments to understand changes that may indicate things being made by different people in different places. We did this doing hyperspectral imaging. I won't go into that, as opposed to regular RGB cameras. And what was interesting there is like, oh, great, these things look different. And now, not only do they look different, I have different plots that are associated with them. And it's still like, and so what? So is that a significant difference or not a significant difference? So we go on with the analysis to do things like go through thousands of pages and cluster the colors, to count the colors, and then see what is the spectral variation within pages to understand what's a normal distribution of color variations as opposed to something that indicates some sort of change in authorship or manufacture. Another sort of long-term thing that's bugged me, I haven't made much progress on, is, like the Google Arts and Culture, they have thousands and thousands of high-resolution images. Like, what can we do with them? What is anybody doing with them? So one thing is studying crack patterns in the paintings to understand where the cracks came from, what can we do about them. And if you're lucky, and on Rembrandt's face or his hat, you have light paint, you can sort of see them. Although even here, extracting them reliably with image processing is difficult. And so I've had various students start on this and get frustrated. A brilliant idea that Lukáš brought us, who recently was at the Yale IPCH and is now running an analysis lab in Poland, working with the Yale Center for British Art, is this idea of using X-rays of the images rather than just trying to see the cracks on the images. So there's an X-ray, and you have to see it close up. Okay, the cracks are harder to see, but there's a lot less in the way of them as far as dark paint, light paint. So we have a chance to extract the cracks from the X-ray and then learn, using deep learning, the relationship between those cracks and the appearance of the painting, so that then once we learn that, we can probably, at least to some extent, detect cracks in paintings that we don't have the X-rays for. It's not a slam dunk. There's a lot of work to do, but it's a great idea that we'll be pursuing. On the last topic I wanted to touch on, which was already mentioned, is this problem of heterogeneous data. You've got all sorts of information, and this is similar to, I think, the last couple of projects you were talking about, so I think we may have some overlap in tools we might want to develop. This is Elihu Rubin from the School of Architecture has developed this over many years through a course he teaches, where students document details of buildings in New Haven. The idea is history is not just the great persons, the famous buildings, but it's our communities. It's where we live, and where we live is New Haven. So documenting the individual buildings in New Haven. This is something that Saima Akhtar, who's here, has been working on as well as Benedict. So in this archive, each student's responsible for finding as much as they can. That includes maps from the library. It includes scans of permit applications for changes in the building, lists of who occupied it through time, just every little scrap of paper associated with transactions, historic photos, stories, social history, so that we're getting this database of of New Haven. So then the question is, now we're getting this great heterogeneous database, what kind of studies can we do, and what tools would be needed to go across this corpus of images and texts? So that's what I wanted to bring up with sort of these ideas, like why aren't we using 3D? We need context. Where did the data come from? And more things like, what was the date of the postcard and so forth. And 2D, this enhancing the data with new correlations from labeled samples, and just new tools for learning from heterogeneous data. So, thank you.
Thank you so much.